Good morning and welcome to today's lesson. We are going to look at theoretical probability. Yesterday we were looking at how we describe a chance, and we had two ways in which we describe chances. We were to describe a chance in terms of words, which we said is a very vague way in which you can describe that chance, or alternatively we had to look at spinor proportions, whereby you had the option of using fraction, decimals, or percentages as a way of describing the probability of that event happening. So today we are having theoretical probability, and when we are talking about theoretical probability, we are simply talking about the chance of an event happening, the actual chance of an event happening. We are not carrying out any practical in this case, but whatever is happening is there is that expected chance. There is a chance, like for instance, when you are tossing a coin definitely has two sides, the head and the tail. So if you are tossing that coin, then it is expected that the probability of having a head is 1/2, then the probability of having a tail should also be 1/2, because these two events of tossing a coin are having equal chances of occurring. So it is expected, it is the actual expected probability of tossing a head or tossing a coin when you are, tossing a head or tossing a tail when you are tossing that given coin is just 1/2. That is the expected. So when you are talking about theoretical probability, we are simply dealing with the actual chance of that event occurring. So that actual chance of the event occurring is whatever we are referring to as the theoretical probability. So we are looking at theoretical probability, but it is in single step. So when you are having just a single step in carrying out the theoretical probability, what is expected of us? We are going to look at this using questions for us to understand best. But it is important to note that in theoretical probability, the probability of an event happening is given by the number of favorable outcomes So we are having number of favorable outcomes over the total number of outcomes. So we started by defining the terms that are used in probability. And we said that the favorable outcome is that outcome that has been considered, that it must appear in any given situation. So that outcome that is favored, that it is a must, it appear in that given event, then that is what we are saying is favorable outcome over the total number of outcomes that are in that given case. So we have some few questions to deal with as we are looking at theoretical probability. For instance, So we are having the question that a fair six-sided die is rolled. So one thing that we have to note is that we are being told that this die is fair, meaning a die, this is a six-sided die, then it means it has 6 sides. These 6 sides have equal opportunities or equal chances of them being rolled because it is a fair die. So being a fair die, we are expected to, part A, list the sample space. When you are defining terms used in probability, we said that a sample space is simply all the chances that are expected to occur when an experiment is carried out. So in this case, we are having a 6-sided die. So it has 6 sides, and you're expecting when you are rolling this die, it is possible to roll a 1, it is possible to roll a 2, it is possible to roll a 3, it is possible to roll a 4, possible to roll a 5 or a 6. So the sample space of this given activity is 1, 2, 3, 4, 5, 6, and it should be in that given form. Then next we are being asked, find the probability of rolling a 3. So what is the probability of rolling a 3? We've already said to get probability of an event happening, then we have number of favorable outcomes divided by the total number of outcomes we have. So in this case, we are looking for favorable outcomes for 3. So what are these outcomes where 3 must occur? So in this case, there is a possibility of rolling a 3. In this case, we are having only 1 3 in that case. So the possibility of rolling a 3, the number of favorable outcome for rolling a 3, then the favorable outcome is 1, then the total number of outcome is 6. So it means the probability of rolling a 3 is 1/6. Then next we have find the probability of rolling an even number. So we need to identify what is an even number. An even number is simply a number that is divided by 2. So we, in our sample space, identify the even numbers. So we have 2, we have 4, and we have 6. Those are the even numbers we have. So we find out how many even numbers do we have. We find that this is 1, 2, 3. So it means the favorable outcome in this case is 3. So probability of rolling even, probability of rolling an even number will be given by the favorable outcome, which are 3, divided by the total number of outcome, which is 6. We can simplify our fraction. 3/6 is simply 1/2. Part D of the question. So we are being asked to find the probability of rolling a number that is less than 3. So we check on our sample space. We have 1, 2, 3, 4, 5, and 6. Then we find out which numbers are less than 3 in this case. So the numbers that are less than 3, we have 2 and 1. Those are the numbers that are less than 3. So what does it mean? The favorable outcome in this case are 2. Then the total number of outcome is 6. Total number 6, total number of outcome 6, favorable outcome 2. So probability of rolling a number that is less than 3, then will be the favorable outcome, which is 2, divided by the total number of outcome, that is 6, and 2 over 6, if simplified, is simply the same as 1 over 3. So it is important to note that when we are talking about probability, we said we have 3 options. You can either write your answer as a fraction, you can either write the answer as a decimal, or you can convert it to percentage. So my answer is in form of a fraction, but that doesn't limit you from writing that answer in form of a decimal or in form of a percentage. So we have the second question, or the second example that we are looking at, that is letters in the word maths are written on 5 cards and then one is drawn from the hat. So the first question is list the sample space. So we are supposed to list the sample space. We have the word maths. So the word maths has the following letters. We have letter M, we have letter A, we have letter T, we have letter H, and letter S. So we find out what is our sample space. Our sample space, what does it contain? So we find that it contains 1, 2, 3, 4, 5 letters. So we find that the list of our sample space is 5. Part B of the question. B, we are asked to find the probability of drawing letter T from that given hat. So probability of drawing letter T, we've already said that our sample space contains these letters. So it contains those letters. So we find out how many favorable outcomes do we have for letter T in the word. So in this word, we discover that we only have one favorable outcome for letter T. So since there is only one favorable outcome and the total number of outcomes in this case is 5, so it means that probability of drawing letter T from that given hat will be the number of favorable outcome, which is 1, divided by the total number of outcomes, that is 5. So we find that the probability of drawing letter T from the hat is simply 1 over 5. Part C. Part C, we are supposed to find the probability of choosing a consonant from this word. So we first need to know what is a consonant. Then from there, we will be able to identify which ones are consonants and which ones are not. So we all know that we have vowels and consonants. And out of the 26 letters of the alphabet, then we are having the vowels as so we have 5 vowels, then the rest of the letters are consonants. So these ones are vowels. then the rest of the letters will be consonants. So we find out, in this case, in our word, then we only have one vowel, that is the A. Having this one vowel, it means the remaining of the four letters, the rest of the four letters are simply consonants. So in this case, we have M, we have T, we have H, and we have S as the consonants we have. So 4 out of the 5 letters we have are consonants. So what does it mean? Probability of choosing a consonant, then the number of favorable outcomes we have are 4. Total number of outcomes is 5. So it means probability of choosing a consonant from that given word, then it is 4 out of 5. So the last question on that, we are being asked to find the probability that the letter drawn is also found in the word term. So we are having the word maths and we also have the word term. So we need to find out which letters are in this maths that is also in this word term. So we find out. So if this is my letter, then M is here and it is also there. A is found in the words maths, then it is also found in the words term. Then T is also found in term and maths. H is not here. S is not here. So it means how many letters do we have that are appearing in these two words? Then we have 1, 2, 3. So we have 3 letters in maths that are also appearing in the word term. So what does it mean? The favorable outcomes in that case are 3, then the total number of outcome are 5. So the probability of getting a letter that will be drawn that is also found in the word term then is 3 over 5. So question 3, a bag of marbles contains 3 red marbles, 2 green marbles, and 5 blue marbles. They are all equal in size and weight. It is important to note that they are equal in size and weight. What does it mean? It means that it gives them all equal opportunities. There is no favored marble in this case because all of them are equal in size and weight. So when you are picking, you can't really identify which one are you picking. But if the weight was different, then you will identify the marble from its weight. If the size was different, you will identify the marble from the size. So they are all equal in size and weight, so that they are all given equal opportunities of being chosen. So when a marble is chosen at random, part A, we are being asked what is the probability that a blue marble is chosen. So we need to get the probability of choosing a blue marble. And we simply said that to obtain the probability of a given event, in this case our event is a blue marble. So probability of picking blue or choosing blue from this bag of marbles, then it will be the number of favorable outcome over the total outcome. So what do we mean? We need to get what is the favorable outcome in this case. But to get the favorable outcome is simply identifying how many blue marbles do you have. So in this case, we are having 5 blue marbles. So in this case, blue marbles that we have are 5. Total outcome, total number of outcome that we have, then it means we need to get the total number of marbles that are available in this bag. So we are having 3 red, 2 green, and 5 blue. So it means the total number of marbles we have will be 3 plus 2 plus 5. 3 plus 2 plus 5 is simply 10, because this is 3 plus 2, which is 5. 5 plus 5 will give us 10. So the total number of outcomes in this case are 10. Then the favorable outcome for blue will be 5. So it means probability of picking blue from this bag will simply be favorable outcome, that is 5, over the total number of outcomes, which are 10. So 5 divided by 10 is simply 1/2. Or as a decimal, it can be 0.5. As a percentage, you can have 50%. Part B, we need to find the probability that a red marble is chosen. So probability of choosing a red marble, then we need to find out how many red marbles are in this given bag. So we find out that we have 3 red marbles. So it means the number of favorable outcome for red, so probability of picking red, then it means number of favorable outcomes for red is 3. Then total number of outcomes were 10. So it means probability that a red marble is picked, then it is 3/10. So we can still go ahead, convert that to decimal. 3/10 as a decimal will be 0.3. Then as a percentage, that is 30%. So whichever option you prefer, it is allowed. So we are being asked, what is the probability that a green marble is not chosen? So this is the case that the probability that it is not chosen. So we have 2 options in which we can handle in this case. So if the bag is containing 3 colors, it has red, it has green, then it has blue. So the probability that a green marble is not chosen, as we were looking at complementary probabilities, we simply said that then probability of an event happening plus the probability of another event not happening, then it will give us 1. It will be equal to 1. Or alternatively, probability of not choosing green. If this person doesn't choose green, then it means that he has chosen red or he has chosen a blue marble. So in this case, the probability of not choosing green then gives an opportunity for either a red marble or a blue marble to be chosen. So in this case, we are having the first option that if green has not been chosen, then there is possibility that a red marble has been chosen or a blue marble has been chosen. So it is important to note that when you are using or in probability, then it simply means that this is simply the probability of choosing red plus the probability of choosing blue. And we find that in our first and second part of the question, we've already obtained the probability of choosing red and probability of choosing blue. So the probability of choosing red was 3 out of 10. Then probability of choosing blue is 5 out of 10. So that when we add, we get that probability of not choosing green will be 8 over 10. And if we simplify 8 over 10, it's simply 4 over 5. Or this is 0.8 or 80%. So that is the first option we have. Alternatively, we can decide to find probability of choosing green. So from the question, probability of choosing green, green has 2 favorable outcomes. So we are finding that number of favorable outcomes are 2 over the total number of outcomes, which is 10. So the probability of choosing green will be 2 over 10. Then it means probability of not choosing green. Probability of not choosing green. Complementary events, we said if this event, the probability of one event plus the probability of the other event should give us 1. So this is the one event that has occurred. That is the probability of choosing green, which is 2 over 10. But we now need the probability of not choosing green. But we know probability of choosing green plus probability of not choosing green is 1. So that means if I need to get the probability of not choosing green, then I'll have 1 minus the probability of choosing green, which is 2 over 10. So 1 minus 2 over 10, this is just the same as 10 over 10 minus 2 over 10, which will give me 8 over 10. And that is, if we simplify 8 over 10, then we have 4 out of 5 as the required answer. So you find that whichever option you use, the answer is still the same. So we are having another question. A bag contains various colored marbles. Some are red, some are blue, some are yellow, and some are green. You are told that probability of picking red is 1/2. Probability of picking blue is 1/4. Probability of picking yellow is 1/6. Then you're not told the probability of selecting green. So you've been given probability of red, you've been given probability of blue, you've been given probability of yellow. But we do not have the probability of green. So the question is, if there are 24 marbles in that given bag, so if the bag has 24 marbles, then part 1, how many marbles are there of each color? So we need to get each color, how many marbles are there in this bag. So this is a bag that is containing various colored marbles. So we are having their probabilities. So using the probabilities we have, we need to calculate the number of marbles for each color that is present in that given bag. So the probability for red we've been told is 1/2. So we are having the probability of selecting red is 1/2. So it means if the total number of marbles in this bag is 24, then we need to get how many red marbles are in this case in this bag. Then we will use the probability that we've been given for red. So probability red, its probability is 1/2. So what does it mean? That the number of red marbles will be 1/2 multiplied. Number of red marbles will be 1/2 multiplied by the total number of marbles in the bag, which is 24. So 1/2 times 24, it's simply 12. So we find that we have 12 red marbles. Next, blue, its probability of choosing blue is 1/4. Then we know the total number of marbles has not changed, it is still 24. So to get the number of blue marbles, then we will take its probability, which is 1/4, multiply by the total number of marbles, that is 24. So we have 1/4 times 24, we get there are 6 blue marbles. So keeping in mind, red, we have 12, blue, we have 6. So we need to get how many yellow and green do we have. So yellow, we've been given the probability, and the probability of yellow is 1/6. So probability of picking a yellow marble is 1/6, and being the probability is 1/6, then to get the number of marbles that are yellow in color, then we have the probability, which is 1/6, multiplied by the total number of marbles, that is 24. So we have 1/6 times 24, we are getting 4 yellow marbles. So we've not been given the probability of selecting a green marble, but you already have all the other marbles. We have red are 12, blue are 6, yellow we are having 4. So what does it mean? If the total number of marbles is 24, then red are 12, blue are 6, yellow we are having 4. Then it means if we add these and get it from the total, we subtract from the total number of marbles in that given bag, then they will give us the number of green marbles we have. So we are talking about the green marbles will simply be obtained by the total number of marbles, which is 24, then minus the sum of the other colors we have, which is 12 plus 6 plus 4. 12 plus 6 is 18. 18 plus 4, that is 22. So we have 24 minus 22, and we get the answer as 2 marbles. So we find that the green marbles in this bag will be 2. So green marbles available in the bag are 2. That was part 1 of the question. Part 2, so after we've obtained the number of marbles we are having for green, then the next question requires us to find the probability of getting a green marble from that given bag. So we discovered that the number of green marbles were 2. So we are having 2 green marbles, which means the number of favorable outcomes for green are 2. Then the total number of marbles in this given bag were 24. So that means probability of picking green marble from that given bag will be the number of favorable outcomes, which are 2, divided by the total number of outcomes, that is 24. So 2 divided by 24, if we simplify, then we have 1/12. So still on the same question, but in this case, the first case we were working with a total of 24 marbles, but now we are having a total of 36 marbles in this given bag. The probabilities has not changed, so we are still having probability of picking red to be 1/2, probability of picking blue is still 1/4, probability of picking yellow is 1/6, but we still don't have probability of picking green. So we are still using the same probabilities to answer the questions that we have. So we are having 36 marbles in that given bag. We need to find how many marbles there are of each color. So we find out how many marbles are there that are red in color, how many marbles are blue in color, how many are yellow in color, and how many are green in color. So it means probability of red was 1/2. And if the probability is 1/2, then it means the red marbles in this given bag will be obtained by 1/2 multiplied by the total number of marbles, which is 36. So 1/2 times 36 is 18. So we get that red marbles in this bag are 18. Then blue marbles, the probability of picking blue is 1/4. So it means to obtain the number of blue marbles in the bag, we'll have 1/4 multiplied by 36. 1/4 times 36 is simply 9. Then probability of picking yellow we've been given is 1 out of 6. So it means the number of yellow marbles in this given bag will be 1 over 6 times 36. 1 over 6 times 36, we get 6 marbles. So we need to get the number of green marbles, and since we already have the number of blue marbles, yellow marbles, and red marbles, then we can simply obtain the number of blue marbles by subtracting the total number of marbles in the bag minus the sum of the red marble, blue marble, and yellow marble. So the total number of marbles in this bag are 36. Then minus, we are having the red marbles are 18, the blue marbles are 9, then yellow marbles we have 6. So we have 18 plus 9, that is 27. 27 plus 6, we have 33. So we are having 36 minus 33, and we have 3 marbles that are green. This is green but not blue. So we have 3 marbles that are green in color. So green marbles will simply be 36 minus 33, which gives us 3 marbles. So the green marbles in the bag are 3. After getting the number of green marbles in that bag, then it means it is possible for us to get the probability of green marbles in that given bag. So the second part of the question is requiring us to find the probability. So we already have the number of green marbles to be 3. The total number of marbles in this bag are 36. So it means the probability of getting a green marble will be the number of favorable outcomes, which are 3, over the total number of outcomes. In that case, there are 36 marbles. So 3 over 36, if simplified, is just the same as 1 over 12. So the last part of this question is we are asking ourselves, does the probability of getting a green marble depend on the total number of marbles we have? And the answer is no. Because when you are having 36 marbles, the probability of getting the green marble is still 1 over 12. When we are having 24 marbles, the probability of getting a green marble was still 1 over 12. So as long as the probability of getting the other colors, that is red, blue, yellow, are maintained, then the probability of getting a green marble does not change. So the probability of getting a green marble will be maintained as long as probability of getting yellow, probability of getting red, and probability of getting blue is maintained. The number of marbles in the bag will not matter. So that brings us to the end of theoretical probability. In our next lesson, we shall be looking at experimental probability. Thank you.